Hello, welcome back, welcome to everybody. I would like to introduce a completely new project I'm currently working on. This is the first video of this new series. It's a digital to analog converter, and as I think it's coming out really very well, it sounds very good, very smooth. I think it's worth dedicating a couple of videos on that. As you will see, this is based on two PCM56P chips, and I have at the output of those I have deployed vacuum tubes output stage based on two 12SL7 tubes. Also, the unit is equipped with vacuum tube rectifier. And finally, the user interaction is based on Arduino, which drives a touchscreen Nextion display as well. So I hope you enjoy the video, and thank you very much for your attention. This is a global front view of my new digital to analog converter. You can see it on the right, paired with my very beautiful Sensui AU-X11 integrated amplifier. Little bit of a recap of the main specifications of my digital to analog converter equipment. First of all, this is a non-oversampling DAC. Secondly, it provides 6 user-selectable inputs, audio digital inputs. 4 of them are external, so the equipment on the back has 4 RCA plugs for 4 SPDIF inputs. 2 of them are internal, so the equipment has 2 internal modules, which are the digital radio and the Bluetooth module. Then, as I mentioned before, the equipment has vacuum tubes output stage, which are based on 2 12SL7 vacuum tubes in cathode follower configuration. The anode voltage for those tubes is provided by means of an EZ80 rectifier tube. Then you might see this very beautiful display on the right of the equipment. This is a Nextion touchscreen display, which is driven by Arduino. Finally, the unit comes complete with the remote control, which can allow the user to select the input and to adjust the volume. In this picture you can see the display as I have currently programmed. This is a touch screen display, so you can see the buttons and the user can act on those buttons, on those controls, just by touching them. So on the left you can see the input selection buttons, and on the right the volume control buttons. The user can select one among those 6 inputs. You can see them reported as blue buttons. The 4 blue buttons on top are for external inputs, external SPDIF inputs, for example TV, so audio digital coming from TV, an auxiliary input, audio coming from CD player, and finally SPDIF signal audio coming from a sound card. The 2 blue buttons reported on the bottom of the picture are for selecting the internal digital sources. One is the digital radio, the other one is the Bluetooth module. The 2 green buttons on the right can allow the user to select to change the volume, and in fact the unit is equipped with a motorized potentiometer driven by Arduino. So if the user presses the volume up, Arduino sends a command in order to drive the motor, in order to turn the volume potentiometer clockwise, and vice versa for the volume down button. In this picture you can see what I would call the core part of the digital to analog converter. The digital audio SPDIF signal the user has selected among the 6 possible inputs we have seen before is fed into the input of the green module you can see on the top right of this picture. This is a digital receiver. It's a CS8414 integrated circuit, which basically provides synchronism and clock, and it's basically the interface to the following stages, which are basically the 2 PCM56P integrated circuits. Those are the real converters, so they convert bits to voltage, and at the output of those 2 integrated circuits, of those 2 PCM56P chips by Bar Brown, at the output of those I have my audio analog signal. This signal is then amplified by the following stage, by the following tube stage we will see in the next section. One particular mention on the power supply. This is very important for sake of audio quality and stability of every DAC circuit, and it's very important to, for example, to separate the analog part from the digital part within the board you are seeing now. So in order to accomplish that, the power supply module, you can see it in the top left part of this picture, the power supply module has to provide several separate stabilized voltages. The analog audio signal I have at the output of the 2 PCM56P chips we have seen before is then fed to the input of the tube stage, which is based on those 2 Fivre 12 SL7 tubes. They are configured in cathode follower layout in order to get a pretty low impedance in order to drive the preamplifier or the power amplifier. So this stage includes a low-pass filter as well, a second-order low-pass filter. This is the EZ80 rectifier tube, which provides the anode voltage to the 2 12 SL7 output tubes we have seen before. Particular care was taken in order to get as low ripple as possible on the anode voltage. This is the input selection board. As I mentioned before, the user can switch between 6 different possible inputs. 2 of them are internal, digital, radio and Bluetooth. 4 of them are external, are coming from outside. The user interaction, as I mentioned before, is based on Arduino, so those 6 relays are driven by output signals coming from Arduino. In order for the user to select one particular input among the 6 available, it's possible to act either on the remote control or on the touchscreen display. This is the main part of the Arduino-based logic. From top to bottom, we can find the Arduino Mega core on the top of the picture. Going below, we have this blue shield I have deployed in order to properly drive the input selection unit we have seen before. The last two boards are part of the digital radio module. These are two boards which I have purchased, and I'm currently in the process of adjusting the Arduino configuration in order to properly drive them. In the previous sections of this video, we have seen each stage, each piece of this exciting project separately. Now in this picture we can see everything fitting together in the global layout. So looking at the picture starting from top right and going anti-clockwise, we can see first of all the power supply sections. There are many transformers, one for the anode voltage, another one for the heaters supply, again another one for the digital to analog converter module. Then again going anti-clockwise, we can see the filtering section for the anode voltage. Again you can see the input selection unit. This is vertically installed. Then we have the core part of the DAC module. You can see the receiver, the digital receiver, and you might see the two PCM56P integrated circuits. Then we have the two 12SL7 output tubes. Then we have the Arduino logic we have seen before, and finally we have the Nextion touchscreen display. You might see it, it's of course vertically mounted. So we have seen many things, many circuits, but at the end, which is the outcome of all that? So in this picture, you can see the measures, the result of the measures I have taken on the circuits, and I have to say I'm very happy about the outcome. As you can see, the distortion is very low, is 0.042%. This is very good if you consider that this includes also, of course, the tube output stage. Also, the pass band is flat from 20 Hz to a little more than 18 kHz, which is really good, and this is exactly what I wanted. A little bit of a roll-off, more or less at 18 kHz. This is due to the low-pass filter, to the second-order low-pass filter I have implemented. Also, noise floor is very low, is at least a minus 95 dB. This is due to the particular care I have taken in the deployment, for example, of the tube output stage. Really no hum nor noise coming out from the unit, really dead quiet when not playing any music.